Hello students, this is the Digital Knowledge Irshad Academy with a new video of closed loop gain non-inverting feedback amplifier. Before going to circuit description, subscribe my channel and press bell icon so that the next video reaches you. Looking at the circuit, we have feedback amplifier R1 and R2. They are connected across output control generator AV input 1. The voltage which is across R2 is taken and fed back at the input, and this voltage is called V input 2 feedback voltage, and this is the source voltage V input 1. The difference of the two is V input and is applied across ZI. This circuit has already been explained, and now we are going to solve two numericals to see how the gain is stabilized by feedback, applying feedback voltage. Now this is closed loop gain non-inverting amplifier. We are going to solve one example. A is 2000, gain is 2000 and it varies to 7000, or 1 is 200k, R2 is 1k, 1 kilo ohm. We know that beta is equal to R2 over R1 plus R2, and this is equal to 1 kilo ohm divided by 200 kilo ohm plus 1 kilo ohm. And we know that when two resistances, one with the high value and one with the low value, are connected in parallel, the low value resistance can be neglected, and this can be neglected, and we can write 1000 over 200,000. This 3 zeros cancel with this, and we are left with 1 over 200. This is nothing but 0.005. This is our beta. This is our beta. And loop gain is equal to A naught beta. Let us find out for 2000. For 2000, A naught is 2000, beta is 0.005, becomes this. These 3 0 cancel with these 3 0. The beta for 2000 comes as 10. For 7000, it is 0.005. These 3 zeros cancel with this, and it is 35. Loop gain for 2000 is 10. Loop gain for 7000 is 35. Now feedback formula is AF is equal to A naught over 1 plus A naught beta. A naught is 2000 over 1 plus A naught beta for 2000 is 10, and it becomes as 2000 over 11, and this is nothing but 182. Let us find out gain with feedback for 7000. 7000, it is 1 plus A naught beta for 7000 is 35. We can write 7000 over 36, and it is nothing but 194. Let us now see that without feedback when we were not giving feedback, let us see the variations. We say that for 2000 gain, the variations in gain was 5000. Why? Because it was 2000 and it varies to 7000, and the variation in gain is 5000. We have written 5000 here. For 1, the variations in gain is 5000 over 2000. For 100, the variations in gain is these 3 zeros cancel with these 3 zeros, and 5 multiplied by 100 becomes 500 divided by 2, and this is nothing but 250% variations in gain when we were not giving feedback. Now let us see, we have given the feedback here, gain with feedback. Let us see the variations. With feedback, for 182, the variations in gain is 12. For 1, the variation in gain is 12 over 182. For 100, the variations in gain is multiplied by 100 and becomes 1200 divided by 182, and by calculator or when you divide it, it comes as 6.6%. See that when the feedback was not given, without feedback the variation in gain was 250%, and when we have given the feedback, the variations had reduced to 6.6%. The gain has been stabilized, the gain has become stable, but there is a reduction in gain. Now let us solve part 2 and see that A is 2000, which varies to 7000. R1 is 200K, but this time R2 has increased 10 times, and from 1K we have increased to 10K. The feedback voltage is going to increase. Let us find out beta for this is R2 over R1 plus R2. R2 is 10K, it was previously 1K, and now R1 plus R2 200K plus 10K, and it is 10,000 divided by 210,000. Now these 4 zeros, these cancel with this, and we are left with 1 over 21, which is nothing but 0.05. Beta now is equal to 0.05. Previously it was 0.005. Now it has increased to 0.05. Now let us calculate A naught beta. A naught beta for 2000 is 2000 multiplied by 0.05, and these two zeros cancel with this, and 5 multiplied by 20 is 100. Loop gain now is 100. For 7000 multiplied by 0.05, these two zero cancel with this, and it is 350. A naught beta is 350 for 7000. For 2000 it is 350. Let us now calculate AF is equal to A naught over 1 plus A naught beta. This A naught is 2000 and 1 plus A naught beta for 2000 was 100, and it comes out to be 2000 over 101, and if you divide it, it comes as equal to 19.8. You will be surprised to see that the gain 2000 has reduced with feedback. When we have without feedback it was 2000, but when we have given a feedback it has reduced to 19.8. For 7000, 1 plus 350 A naught beta, and it is equal to 7000 over 351. This is nothing but 19.95 approximately. Let us now see without feedback. The variations in gain was, as we have already calculated, was 250. We can again calculate. For 2000, the variation in gain was 5000. For 1, it is 5000 over 2000. For 100, these three zeros cancel with this. This is 500 over 2, which is 250%. When the feedback was not given, the variations in gain is 250%. And when we are now in the second part, we are giving feedback. The feedback has increased by 10 times. With feedback, the variations in gain is for 19.8 gain, the variations in gain is 0.15. This is 19.80. This is 19.95. The increase for 1, the variations in gain is 0.15 over 19.8. For 100, the variation in gain is will multiplied by with 100. Now this can be omitted and the 0 comes here, and this can be omitted and the two zeros come here. These two zeros cancel with this, and we are left with 150 over 198. If you calculate it, this comes out to be 0.76%. See that? Once the feedback has increased, the gain has become more stabilized. The variations in gain has reduced from 250 to 0.76%, absolutely stable gain. But see that 2000 gain has reduced to 19.8, 7000 gain has reduced to 19.95. So we have stabilized the gain at the cost of reduction in gain. Note, when beta increases from 0.005 to 0.05, the beta has increased by 10 times. Why? Why? Because the R2 was increased from 1 kilo to 10 kilo ohms. Surely it is going to develop more voltage, more feedback. More feedback means the output gain is going to be stabilized, but the output voltage is going to be reduced. With 0.005, the variations in gain was 6.6%, and with this point it has become 0.6%. When beta increased to 10 times, there was absolute no variations in gain, 0.76%. Now let us calculate another thing. We know that beta is equal to R2 over R1 plus R2, and 1 over beta is equal to 1 over R2 over R1 plus R2. Beta is equal to this, but 1 over beta is 1 over this goes in the denominator. This can further be written as R1 plus R2 over R2, and this can further be written as R1 over R2 plus R2 over R2, and R2 cancels with this. We can write this R1 over R2 plus 1, or 1 over beta is equal to 1 plus R1 over R2. See that 1 over beta is nothing but is called ideal closed loop gain. Shows that it depends on the value of R1 over R2, and it is independent of amplifier gain. We'll note this point, that once we have given a feedback voltage, the ideal closed loop gain depends on the ratio of R1 and R2 and not on the amplifier. And with the feedback we have absolutely stabilized the gain, but at the cost of reduction in gain. Now coming to the summary point, the circuit was already explained. This is gain A, part 1. We are going to solve this numerical. Gain A is 2000, it varies to 7000. R1 is 200 kilo ohm, R1 is 1 kilo ohm, beta is R2 or R1 plus R2, 1000 over 1k plus 200 kilo ohm. Two parallel resistance with the large value and one with the small value. Small value resistance can be neglected, and it comes this 1000 cancel with this and it is 1 over 200 and beta now becomes 0.005. Let us now calculate loop gain A naught beta. For 2000 the loop gain is 10. For 7000 the loop gain is 35. Feedback formula is A naught over 1 plus A naught beta. 2000 over 1 plus 10 is 2000 over 11 is equal to 182. See that with feedback the 2000 gain has been reduced to 182. For 7000 1 plus 35. Why? Because loop gain is 35. 7036 is 194 without feedback. For 2000 the variation gain is 5000. For 1 is 5000 2000. For 100 it is this cancels and it comes out to 50% variation when we are not giving feedback. And once we have given a feedback, the variation in gain is for 182 the variation gain is 12. For 1 it is 12 over 182. For 100 it is this and comes out to be 6.6%. Firstly it was 250% when the feedback was not given, and once we have given a feedback the variation has reduced, the gain has become stable. We are able to stabilize our gain. That was the major setback in operational amplifier, that there was a gain was very large but there was a lot of variations. We have been able to stabilize the gain. Part 2, now this time we have increased R2 to 10K. That means the beta has increased 10 times. The feedback voltage has increased 10 times. A naught beta is 100 and for 7000 it is 350. AF is A naught over 1 plus A naught beta. 2000 loop gain was 100 and 2000 over 101 is 19.80. For 7000 the loop gain was 350 and 7000 over 351 is equal to 19.95. Without feedback the variation in gain is 250%, but with feedback 19.8 the variation in gain is 0.15. For 1 it is 0.15 over 19.8. For 100 multiplied by this and the variation in gain has become 0.76. Without feedback the variation in gain was 250%. With feedback it has now the variation has reduced to 0.76%. Absolutely stable gain. Note, when beta increases from 0.005 to 0.05, gain becomes more stable from 6.6% to 0.76%, but gain decreases. Stability in gain is achieved at the cost of gain reduction. Now, we calculated that the beta is R2 over R1 plus R2. 1 over beta becomes 1 over R2 over R1 plus R2. This can be written as, this goes in the numerator, R1 plus R2 over R2. This can be written as R1 over R2 and plus R2 over R2. R2 cancels with R2 and we are left with R1 over R2 plus 1. This can be written as 1 plus R1 over R2. 1 over beta is called ideal closed loop gain and it depends on the ratio of R1 R2 and is independent of amplifier gain. That's all. And see that the feedback, this all takes time in a nanosecond. Moment the gain varies, the feedback voltage varies, which brings it back to the original value. One thing we have to emphasize on this point, that we are able to stabilize the gain to a large extent, but there is a reduction in gain. We have stabilized the gain but at the cost of reduction in gain. That's all. Thank you very much.